Right. This is one of the most important units regarding state feedback controller design and state observer design. There are only two important concepts in the first half of the second unit. That is design of state feedback controller through pole placement, design of state observer through pole placement. So we already know that what do you mean by pole and what do you mean by zero. The pole is nothing but which is a denominator part of the given transfer function. The pole is nothing but denominator part of the transfer function. So how these poles can be located in the S-plane by changing the value of K gain. Here is the gain K constant. So how to these poles can be placed in the S-plane by changing the value of gain K. So that by finding this value of gain K, we can show that the system is stable or unstable, so that it is very easy to design any control system. So to design any control system, definitely we need a stable system. If no control system is design cheyalanunte, we need to have to design a control system with stability. That is, the system is said to be stable or unstable. So look at this one. Before going to design any state feedback controller or a state observer design, let us coming to this one. So this unit consisting two parts. That is a design of state feedback controller, state observer, and the next concept is nonlinear systems. So what do you mean by nonlinear system? What are the different types of nonlinearities? What is the difference between linear system and nonlinear system? That we can discuss clearly in this unit. Let us coming to here. Let us take the first part of the second unit. Let us coming to this one. First one is effect of state feedback on controllability and observability. As earlier we have studied about what is controllability and what is observability. So to find controllability of any system, there are two methods. Also to find observability of the system, there are two methods. That is a Kalman's test and Gilbert's test. Kalman's test, which I have already explained in the previous classes, Gilbert test given as an assignment to you. So what do you mean by a Kalman test? To check the controllability as well as observability. So to check the controllability, we need to form one matrix which is called composite matrix QC. Therefore, the format of the QC is equal to find the controllability. Then we have some equations. That's a column matrix B. The next column will be A into B. The next column will be A square into B. The next column will be A power n minus 1 into B. A power n minus 1 into B. This is a matrix format for the controllability. To verify observability of the system, the composite matrix Q naught is equal to, this is a some row matrix, that is a column matrix. Let it is C, and next one is C into A, and next one is C into A square. Like that, we have the expression. So after finding this composite matrix, we have to verify the rank. The rank is equal to order of the system. We can say system is said to be controllable. The rank is not equal to order. We can say system is said to be uncontrollable. The same way coming to the observability, here also we have same problem. So to find the rank of this composite matrix, we need to use a determinant. If the rank is equal to order of the system n, the system is said to be observable. The rank is not equal to order, then the system is said to be not observable. This is what we studied in the previous session. Now I am going to take what is effect of feedback on controllability and observability. Earlier we have studied about only open loop system. Now I would like to take one closed loop type of system with a feedback K. So other than this D okay. Other than this part, The rest of the part is almost state diagram for the state equation. That is, what is the state equation we had in the previous session? X dot is equal to A into X of t. X dot is equal to A into X of t plus B into U of t. B into U of t. What is output y? Y is equal to C into X of t. C into X of t plus D into U of t. D into U of t. Look at this one. X dot of t equal to A into X of t plus B into U of t. Y of t equal to C into X of t plus D into U of t. So, entire this block diagram will go for the state equation diagram, right? Look at this one. This is remaining state diagram. So this state diagram is designed or drawn for this state equation. Now, what is the difference between both red and blue mark? This blue mark is already designed for the state model. That is for state equation, output equation. We have drawn one block diagram, which is called state diagram. In addition to that, we have to add one feedback with respect to k value. There is an additional feedback which is connected with respect to k. So before adding this value of k, we can find whether the system is stable or unstable by taking characteristic equation, that is Si minus, there is one equation, Si minus mod A is equal to 0. This is a characteristic equation for this. So if we get the S value is, that means the poles are the eigenvalues. Sometimes we can call the eigenvalues, or sometimes we can call roots, or sometimes we can call poles. So if the roots are located in the left side of the S-plane, system is said to be stable. The roots are located in the right side of the S-plane, system is unstable. The roots are located on the imaginary axis, system is said to be marginally stable. This is for the before adding feedback. After adding feedback, what would be the change in the state equation? After adding this feedback, what would be the change in the state equation? Again, what would be the change in the output equation? Now, again, we have to check controllability and observability as well as stability. Is there any modification or is there any changes in the system response? That is what we are going to discuss in this unit. That's why here I'm going to take effect of state feedback on controllability and observability. That means what is the effect of feedback on controllability and observability? So let us come into the how the controllability of the matrix can be changed while adding feedback. How observability of the system can be changed while adding state feedback. Here, what is the state feedback means? The feedback which is connected directly with respect to the state variable. What is the state variable? Here it is X. So that I'm going to take this feedback from the X directly with respect to input with the gain constant K. I can call this is state feedback. I can call this is state feedback. So that you can understand very clearly before adding feedback, after adding feedback, what was the change in the system controllability as well as observability and the stability of the system. That is what I am going to share. What are the effects of feedback on controllability and observability? So let us coming to over here, the next diagram. So it is already designed for the state equation. I am going to connect one feedback from the state variable with a gain constant K, and this feedback is directly connected with respect to one more reference input, where R is the reference input. Now, from this, what are the equations we can develop from entire this block diagram? So let us coming to the first equation. Let us take, this is X stat. If you take integral of this, x dash will give x. Therefore, x dash is equal to, I can write an equation. That means x dot is equal to the matrix A is multiplied with AX. Therefore, the matrix is multiplied with X. Therefore, I can write this is AX plus. What are the values coming over to the summing point? B is multiplied with what? Input. Therefore, I can write this is equal to B into. This is one state equation, right? What is output equation Y? Y is nothing but C is directly connected to the summing point with a multiple of X. Therefore, I can write the output equation Y is equal to C into X plus. What is one more point coming from the input? U is multiplied with the matrix D. I can write D into U. So sometimes this matrix is a null matrix. We are going to be assumed 0. This is called state equation, which is developed for the above block diagram, right? In addition to that, we have one more feedback element. This feedback is we are adding with respect to state variable. That's why it is called state feedback. The feedback is connected to the variable of X. That's why that's the state variable. I can call this is state feedback. When I connect this state feedback to the control system, what is the variation of the controllability? How the observability of the system can be changed? That is what we are going to check. So let us coming to this one. I'm going to write one more equation where U is the system input and R is a reference input. Therefore, I can write the equation for the U. Therefore, I can write U is equal to. What is the U? So here is the input is coming over to here and there is a feedback element with respect to X and K. Therefore, I can write the input is U is equal to R minus K is multiplied with what? K is multiplied with X. That equation. This is equation 1. And this is equation number. Let us assume that this is equation number. So that is U is equal to R minus Kx is also called control law because we are going to control the input here. That's why it is called control law. U is equal to R minus K into X. U is equal to system input. R is equal to reference input. K is a state feedback gain where X is a state variable. Now substitute these two equation in equation 1 in place of U. What would be the change? I will show in the next slide. So let us coming to over here. That means I'm going to show the complete diagram. Afterwards, we can go to the one by one. So when I substitute this equation number 1 in equation 1, number 2 in equation 1, there is a small change. That is x dot is equal to, again I can write x dot is equal to a into x. X dot is equal to ax plus b into what is u? U is nothing but r minus kx minus kx. Now, what is the matrix Y? Because I'm going to assume B is equal to 0. When I take B is equal to 0, there is no U. Therefore, Y is equal to Cx. There is no change in the output equation. The state equation would be changed. Therefore, I can write x dot is equal to. That means x dot is equal to. By simplifying this one, here R is a reference input. I'm going to write one more time. This is AX plus B is multiplied with R minus, again B is multiplied with what? K into X. B into K into X. Now simplify this one. I can write over here. X dot is equal to, finally, X dot is equal to, what is the value over here? Take here is A into X, here is minus B into K into X. Therefore, I can write A minus B is multiplied with the gain matrix K into X to X plus B into R plus B into R. That equation number. Now compare equation 1 and 3. What is the change? Now compare equation 1 and 3. X dot is equal to, in equation 1, X dot is equal to AX plus BU. If you compare equation 1 and 3, you will get X dot is equal to AX plus B into U. But after substitution of the state feedback, what is X dash? X dash is equal to A minus B into K into X. That means here A only matrix which is multiplied with the state variable X. But when you connect a feedback, state feedback to the system system matrix can be modified as A minus B is multiplied with the gain constant K. That means here is A, but when you connect the feedback, the system matrix can be modified as A minus B into K. So look at this one. Before connecting this feedback, what is the characteristic equation of the state equation? So before connecting this one, before connecting this feedback, the characteristic equation would be mod of Si minus A is equal to 0, right? After connecting of state feedback, that is after connecting K value, what is the characteristic equation? Therefore, I can take S into I Si minus, in place of A, what is the value appear in this equation? A minus B. Therefore, I can write this is A minus B is multiplied with K is multiplied with K mod is equal to 0. Look at this one, both the equations. That is this equation before connecting state feedback, after connection of state feedback. What is the change? Here only matrix A will be appear without feedback. When the feedback is joined, there the matrix can be modified as A minus B into K. So if I take proper values of K, automatically we can control the location of the poles. Suppose if I take K is equal to 0, then I will get A minus B into 0. Therefore, I will get the same equation. Both the equations are same. If I take K is equal to some values based on these matrices, 1, 0 or 0, whatever it is, then automatically the system poles can be located either right side or left side. That means by changing this value of K, keep on changing, the system gain changing, automatically the system stability will also to be controlled. That means we can change the poles from one place to other place by changing the value of gain K. So what is the feedback effect? This state feedback can change location of the poles in the S-plane from left half of the S-plane to right side or from right side to left side. This is one of the most important techniques. Before adding K value, after adding K value, what would be the changes? That is what we are going to explain in the next slide. I hope you understand. This is the most important concept. Before addition of state feedback, after addition of state feedback, what are the appropriate changes in the equation, as well as how controllability and observability can be changed. So before adding, after adding, how the controllability equation and observability equation can be changed. That is what I am going to explain in the next slide. Whether the system is, before adding feedback, the system may be controlled or may not be controlled. But when you add the state feedback, the system can change from feedback, controllable or observable. Now look at this one. Use number 17 G21A0251. Serious warning and చెప్తా is number 51. Hello, Babu, who is number 251? Number 251. Hey, Babu, who is number 251? Who is number 251? I'm going to put absent for him. Please inform to him. చూస్తాను లిస్ట్ లో ఎవరి పేరు ఉంటుందో నాకు తెలుస్తుంది కదా. After completion of the class, I will put absent mark for the 251. Until then he respond. తన కనుక రెస్పాండ్ కనుక అవ్వకపోతే 0 ఆబ్సెంట్ పెడతాను టుడే క్లాస్. ఎవరు 51 ఎవరు? Not responding. Okay, let us coming to this one. Finally, I would like to conclude for the today's session what we have to understand effect of state feedback on controllability and observability. So before discussing effect of feedback on controllability and observability, what is the state feedback? First, we need to know. Before connecting this feedback, the system is designed for the state equation as well as output equation. After connecting one feedback with a gain constant k, that too especially from the state variable, it is called state feedback. When you connect the state feedback, what are the changes in the diagram? That means how the system stability can be changed. That is also explained. Before connecting this state feedback, what is the characteristic equation? After connecting the state feedback, what is this characteristic equation? So we have to compare both. When you compare both, then we have to identify whether the poles are located on the right side or left side. Suppose before connecting this k value, if you find the stability of the system, that is SA minus A is equal to 0 mod. If the poles locate on the right side of the system, now if we connect feedback k for the appropriate value of gain constant k, the system poles can be shifted from right side to left side. That's the main important point regarding this state feedback. So that with that state feedback, we can change stability of the system, or also we can check or we can modify controllability and observability of the system. That is what I'm going to say in the next class. First, I would like to take attendance. Let us take attendance. I'm going to call roll number wise. So here I'm going to, now we have only 5 minutes. After that, everyone should join again because the class is up to 10:50. After completion of this one, again rejoin in the meeting. I would like to take attendance. So this concept I will explain in the next class because it takes more time to complete it. Look at this one before I